Many people think that fighter jets simply fly over and drop bombs. But in reality, even ordinary free-fall bomb delivery involves at least four classic tactical methods: level bombing, shallow-angle dive bombing, and loft bombing, low-altitude toss bombing. Different tactics correspond to different targets and threat environments, and can even directly determine whether the pilot makes it back alive. Hello everyone, I'm a wild aviation enthusiast. Today we're talking about the four classic bombing methods used by fighter jets. First is level bombing, from 0 to 5 degrees. When weather conditions are poor, such as thick cloud cover that reduces visibility, or when stealthy penetration is required, fighters are not well suited for steep dives, so pilots often choose level bombing. The biggest advantage of this method is that it allows ultra-low altitude penetration. The fighter uses complex terrain such as valleys and hills for cover, exposing itself as late as possible. After rapidly approaching the target, it quickly releases the bombs in level flight. It is also very suitable for delivering cluster bombs or dispenser munitions that cover a large area. However, level bombing has drawbacks. Because the release altitude is low, the aircraft is very close to the impact point, so the release speed is usually required to be no less than 500 knots. This ensures the pilot has enough time to escape the fragmentation lethal zone created by the explosion. As a result, this ultra-low altitude level bombing profile is highly effective for covering and destroying ordinary armored vehicles or light armor concentrations. Second is shallow-angle dive bombing, from 10 to 20 degrees. This method can be understood as a compromise between level bombing and pure dive bombing. For example, the U.S. Navy's 30-30 tactical bombing profile is of this type. The aircraft first penetrates at ultra-low altitude below 500 feet. At 3 nautical miles from the target, it offsets 30 degrees, then pulls the nose up to a 30-degree pitch attitude and releases the bombs at around 3,000 feet. Compared with pure level bombing, this method offers higher accuracy. Compared with steep dive bombing, it exposes the aircraft for less time. Therefore, it is a form of stealthy penetration attack and is widely used as a tactical bombing technique in modern air forces. Third is dive bombing, from 20 to 90 degrees. This is the method most people are familiar with. The famous World War II Stuka is the classic representative of dive bombers because it could dive at nearly vertical 90-degree angles. Modern fighters rarely perform 90-degree dives anymore. Most common angles are between 20 and 45 degrees. The greatest advantages of dive bombing are high accuracy and strong penetration capability. From the pilot's perspective, the CCIP aiming reticle moves relatively slowly across the ground, making precise release easier. In addition, because the release angle is steep, the bomb impacts the ground at a steeper angle and concentrates more energy on the target. It is therefore extremely effective against hard targets such as bunkers, shelters, and runways. Its disadvantages are equally clear. The steeper the dive angle, the higher the aircraft usually needs to fly, resulting in the longest exposure time. Steep dives also place significant structural loads on the aircraft. In practice, when a fighter is carrying heavy external stores, large-angle dive bombing is often prohibited. The final tactical method is loft bombing, low-altitude toss bombing, a distinctive technique in modern air combat. The pilot approaches the target at high speed below 500 feet. At the moment of release, the nose is pulled up sharply. The bomb is tossed toward the target by inertia while the aircraft can rapidly turn away and escape. In this way, the aircraft does not need to fly directly over the target to complete the attack. Its greatest advantage is obviously excellent survivability. When facing dense enemy air defenses, the fighter can remain outside the effective envelope of the defenses. The low altitude also greatly reduces the probability of being detected and locked on. The trade-off, however, is very poor accuracy. With free-fall bombs or unguided rockets, one cannot expect to hit the enemy. At best, it provides fire suppression. With the development of GPS-guided bombs, this problem has been greatly improved. For example, on the Russia-Ukraine battlefield, Ukrainian MiG-29s have used the French ASM Hammer precision-guided bomb, employing low-altitude approach and rapid loft release. This simultaneously ensures aircraft survivability and weapon accuracy. So the four examples we discussed today already cover the full range of bombing methods from 0 to 90 degrees. You will find that every dive angle has both advantages and disadvantages. Essentially, they are all about balancing bombing accuracy, penetration capability, weapon effect, and aircraft survivability. There is no absolute ranking of which is more powerful or more advanced. Once you understand the key points of each, you will be able to make the truly correct choice among these four methods according to the actual battlefield environment.